Okay guys, welcome to my YouTube channel. Okay guys, what we have today is a distribution board. So today I'm going to take you through how to wire a distribution board. Okay guys, so we have to familiarize with the components. Okay, if you are doing electrical wiring or learning to do wiring and tubing, you have to know the types of fuse that we have. Okay, so these are circuit breakers. They have replaced fuse because long ago, before the invention of these wonderful elements, we were using fuse. So you see this one is rated 20 amps, so you were supposed to put a 20 amps fuse there. So if an abnormality occur, you were supposed it was going to be broken or to be bent out, then you're just supposed to replace it. So this one is better in the sense that you don't have to replace anything. If you connect anything that is drawing more than 20 amps, or the rated amps, it might be 20, so it might be 10 as this one, or 25 as this one, if you can see. So if you are drawing a current that is higher than the required, it is going to trip like this automatically. So you have to call a technician or to try to switch it on by yourself. So this one you can reset it other than a fuse which you used. You're just going to replace it. Okay guys, so this one is called an earth leakage. In some other electrical circuits, you will see what we call an isolator rated 63 amps, if you can see there, or 60 amps, they're just the same. Yeah, mostly it's just 63 or 60. Okay guys, so what happens, the earth leakage, here I'm just using an earth leakage because that one, the 6 amp breaker, this one is a double pole. If you can see, what do we mean when we say double pole? Okay, it's a single element that is two connections in and two out, as compared to this one which just have in then out. So it's a single pole because it just have one inlet wire and one outlet wire. Okay, so guys, the purpose of this one, when there is a what we call earth leakage, or when the earth is in contact with either the neutral wire or the live wire. Okay, in this case the neutral wire is in black and the red wire is the live. So if any of these wires is in contact with the earth wire, which is this one, the earth leakage is going to trip. Okay, thereby protecting the people and animals. So what happens is that this thing, it protects animals and people. So if I have an electric shock, it should be enough to trip this one, because if you can see on this one, it is not written. Okay, 0.03 amps. If there is any balance of that amount, then it is going to trip 30 milliamps. Okay guys, so basically what we do is we have our inlet wire. This one is from the grid to the wire that we have right here. So we're going to connect it on the double pole, the earth leakage on top. This one is written N, so it shows that this is our neutral pole and this one is our live pole. So this is from the grid, this is the live and this one is the neutral. Then after that we have to switch it off or on. So if you switch this one off, everything else will be off to this side. So now we have the neutral wire from this side, from here on top, it's going down. So here at the bottom, we're just connecting it to the rail or to the connector here, or just sharing the neutral for other circuits, for the lights and for the oven and etc. Okay, so the live wire is here. We take it from here, from beneath here, then we take it up, then we put it here. So we're connecting these wires in parallel so that they receive power over there. So right now, if this thing is off, the 10 amp breaker is for lights. If it's off like this, we're having power to this point, but it cannot pass through here. So what happens is, when this one is off, everything that is connected to this side will be off. So when it's on, everything will be on, and this one is for switches, for plugs. Okay, so guys, basically for lights, most of people, they use 10 amps and 15 amps because lights, they don't require too much current. As for plugs, the most used is 20 amps and 25 amps. For stove, this one is just a back room where there are just rooms for bedrooms, so we do not put 40 amps or 35. So that is the one commonly used for oven or a stove. Okay guys, so now we have to know also that if you can see that these wires, they have different thickness. This one is 1.5 millimeter and this one is 2.5 millimeter. So you have to know the capacity or the current capacity of each wire. 1.5 millimeters is the current carrying capacity of 27 amps. So if you're connecting it, you have to make sure that the wire you connect it, I've met a lot of people ask to say which is the right wire for a 20 or a 10. Okay, why there is no, we can say right wire is any wire that is a current carrying capacity that is above the connected breaker. So you can see that this one is a 20 amps, né? But the wire that we have connected here is a 2.5 millimeter, which is the current carrying capacity of 27 amps. So you can see that the capacity of the wire is greater than the breaker here. So that one is perfect, and this one is 10 amps. The maximum capacity, the maximum current that is allowed to pass through this circuit without tripping is 10 amps. So now you can see that this 10 amp light is connected to a 1.5 millimeter, which is equivalent to 20 amps. The current carrying capacity of a 1.5 millimeter wire is 20 amps. So you can see that it's perfect because the rated current for the wire is greater than the circuit breaker that we've put there. So guys, this is basically how you wire. You need to know. Okay, we have 1 millimeter wire, we have 1.5, we have 2.5, we have 4 millimeter, 6 millimeter. So the current capacity for 1 millimeter is 16 amps. The current carrying capacity of 1.5 millimeter wire is 20 amps, and the current carrying capacity of a 2.5 millimeter wire is 27 amps. The current carrying capacity of a 4 millimeter wire is 37. Then for 6 millimeter wire is 47. Okay guys, so basically that's what you need to know, that every time when you connect, you have to make sure that you put a wire that is a carrying capacity more than the circuit breaker. Okay, so this is it guys. If you switch this one, you have to test it monthly. So each and every month you have to press this one. When you press it, if there was power here, it is going to trip. I'll show you. Oh no, I don't think I'll show you, but if you just tap this one is a test, it is going to trip by itself.